Good day, everyone. Today, we will explore how ancient Egypt, Babylon, and ancient Greece laid the foundation of modern science and technology. We will look beyond their monuments to examine their scientific thinking, the practical problems they solved, and the precise tools they invented to do it.
Let's begin in the Nile Valley. Egyptian science was deeply empirical, driven by practical problem solving. When the annual Nile floods erased property boundaries, they pioneered surveying and geometry to map the land. Their primary tool was the harpe donaptai, or rope stretchers. By knotting ropes at a 3:4:5 ratio, they created the perfect right angles, a technique used both to redistribute farmland and to align the Great Pyramids precisely with the cardinal points.
This empirical approach extended to medicine and timekeeping. Rather than relying solely on magic, Egyptian physicians documented case study on papyrus and used honey as a natural antibacterial wound dressing based on observed success. In astronomy, they used celestial observation as a practical tool, noticing that the rising of the star Sirius predicted the Nile flood. They engineered the world's first 365 days calendar divided into 12 months of 30 days, which directly structured our modern calendar.
In daily life, these breakthroughs secured survival and state control. Geometry prevented civil unrest by ensuring fair tax assessments and precise land redistribution after floods. Simultaneously, the 365-day calendar allowed the central government to accurately plan the farming cycle, dictate crop planting, and mobilize laborers for massive state construction projects.
Moving east to Mesopotamia, the Babylonians took a different approach. They were the world's first great data collectors and algebraic thinkers.
Exactly. Babylonian scientific thinking was highly systematic, using red styluses to record data on clay tablets for centuries. They invented the sexagesimal base 16 numerical system. Chosen for its extreme flexibility, 60 is evenly divisible by 10 different factors. This Babylonian innovation is the direct reason our modern world still divides an hour into 60 minutes, a minute into 60 seconds, and a circle into 360 degrees. They used this math to master both earth and sky. Long before Pythagoras, Babylonian scribes used clay tablet equations to calculate geometric areas, canal volumes, and structural weights. In astronomy, they applied these algebraic tables to track lunar and planetary cycles, predicting eclipses with astonishing accuracy. To them, the universe was a predictable machine governed entirely by numbers.
For citizens, this math drove the economy and empire. The base 60 system allowed marketplace merchants to easily divide silver, grain, and oil, without complex fractions. Concurrently, their algebra enabled the state to engineer massive infrastructure, like city walls and irrigation canals, securing the water supply that sustained their thriving commercial hub. While Egypt and Babylon used science and a practical tool, ancient Greece inherited this knowledge and added a revolutionary question. Why?
The Greeks introduced natural philosophy, the radical concept that the universe operates by natural laws rather than the whims of gods. Thinkers like Thales sought physical causes for phenomena like earthquakes and weather. Crucially, they shifted the scientific standard from mere observation to absolute proof using deductive logic and mathematical theorems.
They also developed sophisticated physical tools to these theories. A major innovation was the astrolabe portable mechanical model of the sky made of interlocking brass rings. By aligning it with the stars, Greek scientists could calculate celestial altitude, determine local time, and map a three-dimensional universe into a flat plate. Ultimately, they synthesized the raw data of Babylon in the practical math of Egypt into a universal framework of logic and mechanics.
This blend of theory and technology reshaped civic life and commerce. At sea, the astrolabe revolutionized Mediterranean trade by allowing sailors to safely navigate open waters at night. On land, the shift toward deductive proof transformed politics and law. Citizens in democratic city began demanding logical arguments and empirical evidence in public debates and courts, rather than accepting decisions based on superstition or divine right.
In conclusion, science was a collective relay race of human ingenuity. Egypt provided empirical observation and practical geometry. Babylon contributed systematic data collection and algebra. And Greece introduced the logic to unite it all. Together, these ancient innovations created the fundamental tools, societal system, and thinking we still rely on today.